Hey guys, in this video I am going to show you the solution to a fairly tough AP calculus problem. So let's take a look at the analysis here. What do we have? You are given a function. And the objective is to find the domain of this function. And the function looks like f of x equals ln of, and I'll color code here for the sake of improved visibility, cosine of x. Okay, that's just too light, however, so let's try a slightly darker color. There we are. Cosine of x. And let's close that parentheses. So, how do we find the domain of this function in a way that shows real understanding so we can be sure that it's correct? Well, the way to do it is to combine several facts together. One step at a time, however. First, you take a look at the cosine function and you ask yourself, well, let's graph the cosine function. Okay, so let's draw a y-axis and an x-axis neatly and carefully. There we are. And here, for the sake of simplicity, I will take, and the visibility, I will take 3 spaces to represent 1. So that's 1, 3 spaces represent -1. And now you remember the maximum value of the cosine function is 1 and the minimum value is -1. And the function roughly looks like this. Okay? So now you've got to ask yourself, what about the ln function? Okay? Well, the ln function has this appearance. Passes through 1 here and looks like this, okay? And now, because this is a composition of this going into that, what it means is, remember, the only values that can be fed into the ln function are positive. Some of the outputs, for example, such as this one here from the cosine function, however, are negative. So you've got to restrict the domain, right? Let's draw in those portions of the x-axis that yield only positive values for the cosine function. So let me grab another color here. So from here to here, as an example, any value of x chosen from this interval fed into the cosine function yields a positive value, which then can be fed into the ln function. If we extend the cosine function, so as to reveal its kind of repeating behavior, you see here's another chunk of the x-axis. Any value of x chosen from here fed into the cosine function yields a positive value, which means then you can feed that into the ln function. Now, the inputs into the cosine function are everything from -infinity down to +infinity. However, the outputs are not. Okay? Any value that you feed of x into the cosine function from this interval results in a value on the y-axis that goes between 0 and 1 exclusive of 0. You see? If I choose some values of x from this domain here, once again, all of those will lie between 0 and 1, inclusive of 0, inclusive of 1, exclusive of 0. So in other words, remember, because this is a composition, these are your x's, they are fed into the cosine. The output from the cosine, which is this, becomes the input, into the outer function, which is the ln function. So that goes over here. And just try to imagine that process happen. You see, there we are. That's it. All I've done is, you begin with the x-axis, grab the chunks of the x-axis that yield positive outputs for the cosine function. And here it might be even helpful to draw little arrows like this, right? Any value, let's say I choose a value of x from here. If I bounce it off the curve, it yields a value over here. That's positive. If I choose a value from here, I bounce it off the curve over to the y-axis, it yields a value that is positive. You see? If I grab a value from here and bounce it off the curve, it yields a value that is positive. But regardless of where I choose my x, okay, from which chunk of the x-axis, the output will always be between 0 and 1, inclusive of 1, exclusive of 0. This then becomes the domain, so to speak, to go into the ln function. So that I place it over here, and it looks like this. So you might see several multiple choice answers, and one of them might be something that looks like this is our pi over 2 here, and then this is negative pi over 2. And one of the choices could be A, and you would have negative pi over 2 is less than x, which is less than pi over 2. So you would choose this as a correct interval. In fact, of course, there are infinitely many such little chunks because this function never stops, but you might be given just one. And there you go. So this is one of them, okay? And once again, be sure you understand the process. So you begin with the innermost function with the x, as I've done here. You highlight the portions that yield positive outputs for the cosine function. This and so on, to the right and to the left. Infinitely many such little intervals. Then you might draw little arrows like this to suggest the process. All the outputs here are between 0 and 1. This is turned and becomes the domain for the ln function. So it looks like this. And there you go. So that's how you analyze this, okay? One of the acceptable intervals here would be between negative pi over 2 and positive pi over 2. And I've analyzed it for you as visually as possible. And that is it. Thank you for watching.